Ladies and gentlemen, this is a semester project presentation done as a part of the PV251 Visualization course led by Dr. Barbora Kozlíková. My name is Michal Babacek and I shall entertain you for a few minutes with my recent advances on my school project named Claw, a small data crawler. The biggest part of this project is by a large margin the server-side data crawler and distributed cache with the REST API. However, this video is concerned solely with the visual part, so I'll just briefly skim through the architecture of the system and show the REST API that's consumed by JSON client embedded in my processing suite. Further in the presentation, I'll show you the whole toolchain in operation with some examples followed by a live screencasted demonstration. So let's have a look, shall we? This diagram depicts all parts of the Claw system. On the top there are data crawlers with actually only the Twitter one implemented. The Stack Overflow crawlers will follow later as soon as I'm happy with the Twitter crawler pilot. The main data are poured into an in-memory distributed cache implemented with InfiniSpan, so it can be easily set in a grid of loosely coupled Wi-Fi application server instances. For the data to be persistent, there is a PostgreSQL cache store to which the system evicts records after a certain period of time. At this point, search and analysis is done with Hibernate search using Lucene queries, but in future I would like to leverage Vecka for supervised machine learning. Last but not least, the collected data are visualized with processing, the main object of this presentation. So here is some code. Twitter user graph crawler, that's the main logic of the server-side code. On a timely basis crawls the graph of the friends and followers and mines the data, the documents. We offer EJB service for the server-side REST component. There is the search logic, adding new users to be followed, retrieving documents. Here is the actual REST API offered to the client. There are the standard CRUD operations, plus some search and statistics. And this is the client code. This client is it's packaged as a Maven artifact and it's embedded in the processing suite. It would be a huge pain to implement it in processing itself. It uses Google JSON for deserializing the data that comes from the REST API. And let's take a look at the REST usage with URL. We can retrieve some statistics. One can see there are like 1.5 million retrieved documents already. One VIP user, that's actually Bruce Schneier, a security celebrity, and his more than 9,000 friends, those are people he follows. We can search, for instance, we can search for a term or list documents of a particular user. And among the documents that are actually annotated tweets, something might catch our eye. And these data, these texts that belong to users in the graph, these are the data I would like to visualize with processing. This is the aim of this graphical user interface that will be demonstrated later. The part written in processing is divided in 5 classes. The claw cube is like the main rendering logic, or the game loop, if you will. Data loader, it takes care of loading the data. It cooperates with the client code I showed you a minute ago, and it constructs a list of shapes, and these lists of shapes are I guess with processing they are transferred to vertex arrays, and thus poured directly through to the graphic card, with the exception of rendering like text labels. That's a huge pain, and I have to somehow optimize it, because rendering these text labels, we will see later, it's not done properly with processing. Oh, that's the actual visualization running on my screen, and I will show you a screencast later on. It's nice and tidy. Well, in the course of research for this assignment, I called upon 2 books, Dataflow 1 and Dataflow 2. They are referenced in the description of this video, and they contain an immense well of inspiration I wrote upon. These are some projects, I won't go into details, but they caught my eye with the processing of text, the textual visualizations, and most importantly, browsing data in 3D space. So that's really relevant for my visualization, because I choose the 3D space. Well, what next? There is something else I'd like to show you. Yellow pages, forward, no. Well, that's beautiful, but somewhat irrelevant. Yes, here we go. There are like 3D graphs, cloud visualizations, cluster visualizations, an immense amount of agents being clustered and interconnected. Yet I must admit I'm not sure whether these are like more artistic visualizations or data journalism ones. It's sometimes quite difficult to derive any meaning from them, at least for me. Yes, these are like 3D networks, representations of complex interconnected graphs. Again, playing with text, the text itself as a medium of the visualization. And that's it. Well, without further ado, let me jump straight to the screencast. Well, this represents one Bruce Schneier as a blue ball at the bottom of the cube. I'll show you in a minute. And his 400 friends and their tweets. The time span is between the March 2014 and July 2014. The green cubes are actually ordinary tweets that we are not interested in, and the purple ones contain word NSA in them, and these purple tweets they have their text attached to them. As you can see, with this amount of data, the visualization actually doesn't hold. It's too crowded, and at the same time the problems with rendering text as an array of shapes with processing is slowing the whole thing down. But it's smooth. The jitter is due to the screencast. The red cubes, these represent the friends, but as you can see, the whole perception of the visualization is more artistic than data journalistic. If you rotate and zoom, you can actually find quite easily an angle from which a particular text could be read. But well, let's take a look at again as you can see on the left in the description. Again, we are looking for a word NSA. At this time, only on a set of 100 friends of Bruce Schneier. These tweets they grow in time like flowers from the bottom up, and again we can browse through the text. It's interesting that at some point in time these purple cubes correlate, so it's very clear when this whole NSA hype happened, because all these people, they were retweeting their messages. Well, let's zoom in and out, read some notes. Yes, security breach, malware implanted by NSA. In the ideal version, one would be able to see purple rivers in the mass of green tweets and navigate oneself towards interesting topics. At the moment, it's not possible to click on any text to navigate away. In some future version, I would like to make these texts active, so one could actually follow these tweets out of this representation to the web, to follow these hyperlinks. At the moment it's not possible. Well, let's take a look at a set of 100 friends. Here we go, and look up word GCHQ, British Internal Security Agency, and also we added some span between the columns of tweets. So now it's more clear that the blue ball, it's Bruce Schneier and his tweets. The red cubes are his friends, the people he follows. And from the bottom up, from the red friend up, we observe their tweets in time. There are time stamps attached to the first and to the last tweets in the column. And there are these purple ones that contain word GCHQ. And we can very easily read these texts and follow this hype throughout the mass of ordinary green tweets. As I mentioned earlier, all the shapes rendered with processing are elements in a list of shapes, and processing translates this to vertex arrays that are permanently stored on the graphics card. However, at the moment, the current handling of text with processing actually forces the OpenGL to re-render it again and to transfer it to the graphics card again and again. So this is like a weird hybrid, and the performance is somewhat poorer than it could be. So there is a room for improvement. The movement is smooth. This like stutter or jitter. It's this screencast thing. Well, this makes more sense than the previous examples, but again, it's still perhaps more in the artistic domain than in the actual data journalism one. But I guess with some improvements in future, I believe this project might come useful. Especially, it's worth mentioning that these data are kind of static. During the boot, the application retrieves the data from the server through the REST API and renders them. What I would like to add is incremental updating, so one would be able to watch this visualization and see tweets being added in time. So this whole structure would actually grow in front of one's eyes. And I believe that might come handy, especially with connection to the feature that would allow for clicking on hyperlinks to monitor some coming hype in your social network or among people you would like to watch or follow. Well, I guess that's it. Thank you for watching, and don't subscribe.